function f of x equals 1 over x at any number a. So if you were asked to find the derivative of this function using the definition of the derivative that we just learned, then we can use either this first limit here or the second limit here, whichever one you prefer. Okay. So let's just take the first one. So by definition of the derivative, f prime of a is the limit as h approaches 0, f of a plus h minus f of a all over h. This is our definition of the derivative. So now we just substitute this into our function f of x. F of x is 1 over x. So if I want to do f of a plus h, I have 1 over a plus h. So substituting a plus h into the function 1 over x. Minus f evaluated at a would be 1 over a. And then this whole thing divided by h. Okay with this? Okay. Now we just want to evaluate this limit. So this limit, well, what happens if I try to plug in h? Is 0. If I do direct substitution on this limit. You get division by 0, that's no good. Okay? This always happens, of course, when you have the derivative. When you do the definition of the derivative, if you try to do direct substitution, you'll always get a division by 0 error. If you use the other form and try to plug in b equals a, you get a division by 0 error. So always the game that you're playing when you're trying to compute something using the definition of the derivative is to try to do some algebraic manipulation of your quotient in order to get rid of or cancel out the h that's in the denominator. Okay? So our goal is to algebraically manipulate this guy and to cancel out an h. So I have in the numerator, what can I do? I've got the difference of two fractions. If I try to combine those, what do I need? Common denominator. So if I try to get a common denominator in the numerator, well, I've got a and a plus h with my denominators, so the common denominator is just the product a times a plus h. Okay. So this is 1 over a plus h times a over a minus 1 over a times a plus h over a plus h. And the whole thing is still over h. So I just took my terms in the numerator, multiplied them through by 1, but 1 in different ways, so that I would have a common denominator. So this is the limit as h approaches 0 of a over a times a plus h minus a plus h over a times a plus h. Whole thing over h. Now I've got a common denominator. Now I'm allowed to combine the fractions. So this becomes the limit as h approaches 0. A minus a plus h. What am I left with?
H.
Negative h.
Negative h. Distribute. Okay? So I have, write one more step. A minus a plus h in the numerator of this fraction And in the denominator, I have a times a plus h. And I have the whole thing divided by h, and I don't have any room below anymore. How could I alternatively write division by h? Multiplication by what?
1 over h.
1 over h. So remember, this is like h divided by 1. Division is the same thing as multiplication by the roots. So if you run out of room on your paper, I did. So now combining a minus a, I get negative h over a times a plus h times 1 over h. And now I'm really happy because I see that I have a factor of h in the numerator and in the denominator, and the h's can cancel. Why is it okay to cancel the h? I'm using that h divided by h. Let me write a different color. I'm using that h divided by h is equal to 1, right? Is that always true? No. When is it not true? Unless h equals 0, but is it okay in the limit, even though h is approaching 0? Can I still cancel out this h over h and say that's 1? Why?
Because it doesn't matter what happens in the limit.
Right. It doesn't matter when I'm evaluating limits. I look at what happens near. I look at what happens near 0, but not at 0. Okay. So now I have the limit as h goes to 0, negative 1 over a times a plus h. This is like a rational function. Right? This is a polynomial, constant term divided by a polynomial in h. And how do you evaluate this limit? What do I do now?
Direct substitution.
You directly substitute. H is 0. Now there's no problem plugging in h is 0. So if I plug in h is 0, I get negative 1 over a times a plus 0, or negative 1 over a squared. So the derivatives, if I want to know the derivative of the function 1 over x at any point a, then I would use the formula f prime of a is negative 1 over a squared. Questions? So then let's use this derivative to find an equation of the tangent line to the graph of 1 over x at the point 2, and what's the y? If the x is 2, 1 half. I use the formula. So if I just sketch myself a graph of 1 over x in the positive quadrant 1, and I look at the point when x equals 2, y equals 1/2. Then I want to know what is the equation of this tangent line to the graph. At this point, 2, 1. So what do we know about the tangent line now? We know its slope. What is its slope? The slope is the derivative, right? F prime of A. So the slope of the tangent line, at, what is the A? Is it 2 or is it a half? 2. 2. A is the x. The slope of the tangent line at A equals 2 is equal to F prime of 2. We just came up with a formula for F prime of A. It's negative 1 over A squared. So F prime of A, we computed, is negative 1 over A squared. So plugging in 2, F prime of 2 is negative 1 over 2 squared, or 4. So for my tangent line, my slope, M, is F prime of 2, which is negative 1/4. Now to write the equation of a line, I need the slope, and I need a point on the line. Well, we know a point on the line, right? We know the point on the line is 2, so we know the point x1, y1 equals 2 1/2 is on the line. So if I want to write an equation of the tangent line, I could use point slope form and write y minus y1 is equal to m times x minus x1. And I've computed the equation of the tangent line. Questions? Great. So this is easy, right? This is derivative is the equation, the derivative is the slope of the tangent line, is the instantaneous rate of change of the graph of the function at the point A. It's the limit as h goes to 0, f of a plus h minus f of a